Hello students, here it is the section as amplifiers. So what are the amplifiers? How transistor is used as an amplifier? What is amplification? What is the necessity of amplification? All these points as basic points we are going to discuss about. And what is biasing? What is stabilization? New terms, different biasing methods, single stage C amplifier, CE, common emitter configuration. Already you might have studied in study of transistor chapter. So how transistor in single stage CE configuration can be used? What is the necessity of multi-stage amplification? Different types of amplifiers, that is the classification group of amplifiers. Then transistor can be used in amplifier, but in amplifier how feedback can be introduced, that is feedback amplifiers part. Then dependent on the placement, position of Q point, operating point, 4 types of amplifiers, class A, class B, class AB and class C amplifiers. And last point, that in this chapter it is included as the differential amplifier, which is the basic building block of an operational amplifier, that is the most popularly used op-amp IC as op-amp IC 741. So this you will study in further study part, but basic part that is to be studied as amplifier. So first point about transistor as an amplifier. So already it has been discussed that NPN or PNP, bipolar junction transistor, it can be used as an amplifier. Here it is the symbol of transistor. This is NPN transistor. Here it is the PNP transistor. PNP, this is emitter where the arrow mark is. This is the middle region as base and the third one as collector. Here it is collector, base, emitter. So this is a 3-terminal device. It can be used for amplification as well as for switching action. So transistor can be used as a switch. So on and off, that is used in digital circuit where 2-state operation takes place. 2-state, 0 and 1's language. Here it is amplification. It means whatever is the signal given to this circuit as an input signal. So in this way, the input signal's voltage is very small. Then the transistorized circuit, it has to increase the strength of this weak signal, that is nothing but the amplification. So this is the amplification. But if you observe here, if input is a sinusoidal pattern, output is also increased strength sinusoidal pattern, then it is called as faithful amplification. So transistor can be used as an amplifier. You can apply signal to its input section and that amplified can be taken as the output signal. So in this way, already in the study of transistor, we have discussed common base configuration, which is useful for radio frequency signal amplification, common collector, which is voltage follower, no voltage amplification, but current amplification occurs, which is useful for impedance matching, and CE, common emitter, which is most popularly used as an amplifier, where it can amplify both voltage and current parameters. So here it shows how much is the maximum voltage of any amplifier circuit. So VO max, it is nothing but up to its supply voltage. So whatever is energy tank provided to that circuit part, electronic circuit part, so that makes the output voltage limitation. So VO maximum is possible up to its supply voltage. Suppose supply voltage is plus 9 volt. VCC, single voltage supply is provided, and the gain is suppose 10. So if V in is 10 millivolt, then V out it will be 100 millivolt. So 10 times it gets amplified. So if you make the input as 100 millivolt, output becomes 1000 millivolt, because as we know, voltage gain is equal to VO upon V in. Therefore, VO is nothing but product of input voltage and voltage gain. So voltage gain shows the amplification capacity of that circuit. So here it is possible to make the 100 millivolt signal to become 1000 millivolt, that is nothing but 1 volt. Okay, and when there is 1 volt input, it is expected to be 10 volt as the output, which is theoretically correct, but practically it is not at all possible because maximum supply voltage is 9 volt. So always take care of these theoretical and practical approaches. नेहमी लक्षात ठेवा, थिअरी मध्ये तुम्ही कॅल्क्युलेशन करताय गेन अँड इनपुट व्होल्टेज ॲज प्रॉडक्ट, बरोबर, पण आउटपुट व्होल्टेज हे सप्लाय व्होल्टेजच्या पुढे जाऊ शकत नाही. अँड वेन एव्हर द आउटपुट व्होल्टेज हिअर इट शोज इट इज पॉसिबल टू लिमिट इट अप टू 9 वोल्ट, द आउटपुट विल लुक लाईक दिस. त्यामुळे 9 वोल्ट हा पार्ट, वरचा पार्ट क्लिप आउट झाला, म्हणजेच प्रॉपर जो सायनोसॉइडल पॅटर्न होता तो नाही मिळत, ह्याला म्हटलं जातं डिस्टॉर्शन. सो एनी व्हेरिएशन इन द आउटपुट सिग्नल पॅटर्न as compared to the input signal applied, it is known as distortion. So what is important? What is faithful amplification? It is the process of raising the strength of weak input signal without changing its general shape. No distortion, no clipping. कुठलाही वरचा पार्ट कट झालाय, तो त्या सप्लाय व्होल्टेजच्या लिमिटच्या बाहेर जातोय. This should not occur. So that is known as faithful amplification. But whenever this transistor is used as an amplifier, always there is a need of biasing. So what is biasing? Basically, to bias means to provide external support. For example, there is one hall available, and that hall can be used for different functions. There may be sometimes marriage function, birthday celebration, or sometimes there may be a seminar or a conference. So the function may be different, but the place, venue is the same. So according to the function, the arrangement, it may change. For example, if it is a birthday celebration or marriage ceremony, then there is essential as dais, then mic system, fan, electric, that is decoration part, that is essential. But whenever there is a conference or a seminar, then that sitting arrangement, it has to be changed. But what are the essentials? In that particular hall, there is essential part of basic electricity connection, water system, okay, pure water, drinking water system, then washrooms must be available, then there must be proper parking, there must be proper sitting arrangement. So the location should be as the approachable location, means for transportation there should not be any problem, means it is to be located at a prime center, so that whatever transportation, railway or buses, cabs, they can reach safely. So that location is also important. So all these parameters are basic needs, but the function programs, they are different. Similarly, whenever a transistor is used as an amplifier, here it accepts the input signal. It may be the audio signal or the video signal, sound or picture signal. So the nature of signal, it will change, but the basic parameters as input side, it must be provided with forward biasing, so that emitter can always provide charge carriers as the supply part, and at the output side there must be always reverse biasing. That is the general concept, okay? But basically, what is forward biasing and what is reverse biasing, or in general what is biasing? So here it is. Biasing means, whenever we consider the term as biasing, it shows it has to provide always VBE minimum 0.6 volt to 0.7 volt, so that this will always overcome the depletion layer that is available in between base and emitter. So this is the minimum requirement, that is called as forward biasing part, correct? So input side should provide charge carriers, but at the same time output side VCE and IC, these two parameters, they have to be made available. So what is VCE? It is the reverse voltage which will keep on attracting charge carriers. So to attract charge carriers, reverse biasing is essential. And the movement of charge carriers, it is nothing but collector current. So flow of charge carriers. So in this way, to provide always initial collector current, that is zero signal collector current, or VBE, proper zero signal base emitter voltage at any instant. Any instant, it means whether the input signal is applied to it or not. Always make available the VBE, or else the VCE, that is the reverse biasing part, which will keep on attracting the charge carriers again at any instant. So these two batteries and these two potential differences, they have to be always available, so that even though you change the input signal that needs amplification, so these are the parameters which are always essential. So what is biasing? To provide proper zero signal collector current. Zero signal, whenever there is no signal given for amplification, so this zero signal collector current is always essential. VBE, to provide proper base emitter voltage, so that internal depletion layer, it should get always overcome, that is at any instant. Either input signal is given for amplification or even though it is not given. So that is the essential part. VCE, the collector emitter reverse bias voltage to attract the charge carriers at any instant. So to provide these three parameters, that is nothing but biasing. So this is known as basic biasing part. So here it is as the amplification and its necessary part. But basically, in general, what is amplification? You might have always observed a mic system, correct? Why microphone is essential? So microphone will accept sound waves. They will be given, those electrical pulses, they will be given to amplifier circuit part. That amplifier increases the strength of sound signal, and then that increased voltage will get converted in increased sound format. That is nothing but amplification. So normally mic system, which is amplifier system, which is in general said as public address system. Public address system, correct. Microphone, loudspeaker, amplifier box. So all these components, they contribute for amplification. कुठलाही सिग्नल त्याची स्ट्रेंथ वाढवून घेणं म्हणजे अँप्लिफिकेशन. मग त्याकरता एक एक्झाम्पल आपण पब्लिक ऍड्रेस सिस्टीमचं लक्षात घेऊ शकतो, ज्यामध्ये साऊंड अँप्लिफिकेशनची नेहमीच गरज असते. लाऊड स्पीकर जे बोललं गेलेलं आहे ते लाऊड फॉर्मॅटमध्ये हवंय, दॅट इज नथिंग बट अँप्लिफिकेशन. दॅट इज इन जनरल, बट ऑलवेज इन युअर मोबाईल or laptop or television or any electronic equipment, for example electronic weighing system, any electronic circuit, if you want to consider as an example, always the signal that is having small strength, it has to be amplified, increased strength, then it can be processed and then it can be given in the final output format. So that is the necessity of amplification. For that we can use NPN or PNP bipolar junction transistor, normally in common emitter configuration, so that voltage and current both parameters can be increased. But for that we need three basic parameters to be provided as zero signal collector current, proper base emitter voltage at any instant, and proper collector emitter voltage at any instant. So to provide these three basic parameters is nothing but biasing, which we normally in general call it as forward biasing and reverse biasing. So what are the requirements of biasing? How VCE and IC decide the working condition of transistor? Yes, already we have discussed these points. That shows as the operating point, Q point, that is quiescent point, Q, quiescent, silent, which is dependent on VCE and IC. So VCE and IC, these two parameters are more important as they decide the working condition of any transistor. Normally we label it as VCZ, ICZ. Z stands for zero signal value. No signal is given for amplification. Then how much is the collector current? initially and how much is the collector emitter voltage initially in the absence of input signal. And whenever AC input signal, audio, video, that signal, changing nature signal, when it is given to that transistorized circuit, how much change in VC occur, how much change in IC occur, that will surely going to change the working condition of transistor, correct? And that is used as the operating point part. So operating point, Q point for amplification, here it has to be always used in active region. So already these points, they are discussed in study of transistor part, but as a short revision, here I am giving this idea. VC, IC. Here VC shows approximately VCC supply voltage value, IC maximum value. So this maximum value here it shows as X parameter and Y parameter. X as VC and Y as IC. So there are two basic coordinates for transistor as a switch. Here it shows whenever transistor it is used as a switch, then its collector current will reach to maximum level, which is nothing but VCC upon RC, whereas VC will be 0. So here it is this coordinate. Here it shows VCC upon RC, Y parameter, and X coordinate is 0. So this shows transistor is getting used as closed switch, and off switch it means off, no collector current flows. And in that case VC will be maximum, that will be approximately equal to VCC, because in case of CE circuit, VCE is the output voltage, which is nothing but VCC minus ICRC. So whenever there is collector current 0, VCE, it results to be VCC. So that is IC 0, VC will be equal to VCC. Here it is. X parameter equal to VCC, Y parameter 0. So whenever you connect these 2 points, this line is known as DC load line. Effect of DC voltage, VCE battery, reverse biasing, VCE voltage and collector current. But when you apply the input signal, so in that case, here VB 0, IB 0. So this shows the cutoff region. As you increase VBE, IB1, increase in VBE, IB2. So in this way, we find here IB as saturation, maximum, and at the same time, here it shows this much is the VCE saturation. That is, collector current has reached to maximum level and VCE has been reduced. On collector current maximum ला VC काय पाहिजे, ideally VCE काय पाहिजे 0. मग हे दोन कोऑर्डिनेट्स काय दाखवतात, तर एक दाखवतो हा ऑफ स्विच, ऑफ कंडिशन, आणि हा कोऑर्डिनेट काय दाखवतो, ऑन कंडिशन. आणि हा जो मधला रिजन आहे याला म्हटलं जातं ऍक्टिव्ह रिजन. याचा अर्थ काय, ऍक्टिव्ह रिजन इट मीन्स इन दिस केस as IB increases, IC also increases. So here if you observe, so this much is the increase in collector current. So this is suitable for amplification, correct? So whenever transistor is used as an amplifier, operating point should be placed in active region. But as the signal gets applied, there will be some change in VCE, some change in IC. So if collector current increases, it may enter into saturation region, that is the on action. Or if IC decreases, it may reduce to 0 level, it may come into cutoff region. So that should not happen, and for that, what is essential? This Q point, operating point, it should always remain in the active region. Here it is, suppose the Q point as, for example, VCC is equal to 9 volt. So here it is showing this is close to 4.2 volt, half of 9, that is closer to 4.5 volt. VC is 4.2 volt. Suppose collector current maximum is 10 milliampere. So here it shows it is, for example, 4.7 milliampere. So initial values of these two as Q, VCE is 4.2 volt, initial collector emitter voltage, and collector emitter current 4.7 milliampere. So IC is neither high nor low, VCE neither high nor low, it is in the active region. So transistor can be used as an amplifier. That is the prediction. But whenever VC increases, suppose here it becomes as 8.2, here collector current may reach to 0.007. collector current has been reduced. So here it shows off condition. But whenever collector current reaches to, suppose 9.7 milliampere, here it will show 0.02 volt. So this shows on status, means collector current has reached to maximum level and VC has reduced to closer to 0 volt. So this shows the on condition. So it is essential that Q point must not shift towards cutoff or towards saturation. It has to remain in active region even though signal is applied. And for that, here we must know the dependency of IC, as collector current is dependent on first one, temperature, first parameter. Temperature वर अवलंबून IC बदलू शकतो. And second parameter is the transistor parameters, means transistor is replaced by another of the same type, then VB level may change. So in this way we have to always check in this amplifier circuit, is IC changing dependent on temperature? If it is changing, it has to be compensated. Or transistor is replaced by another of the same type, NPN transistor, but another transistor is used, it has been replaced, then the beta factor, it may not be same, VBE requirement may not be same. So that will change the VCE IC requirements. So in this way, this parameter part, it may change the operating point, and that is to be restricted. So to make IC independent on temperature variation or change in the transistor parameters, variations in transistor parameter, it is nothing but stabilization. काय म्हणायचं त्याला? Stabilization, stabilize करायचं, stable करायचे. So that is the stabilization process. So what is biasing? To provide proper zero signal collector current, to provide proper base emitter voltage at any instant, to provide proper collector emitter voltage at any instant is biasing. But always remember, operating point has to remain in active region. When you apply any signal, audio or video for amplification, it may change VCE, it may change IC, that may change the working condition of transistor. Either Q point may shift towards cutoff or it may enter into saturation. But this should not occur. But there are certain conditions where IC may change. It may change dependent on temperature, or there may be variations of transistor parameter if transistor gets replaced. So to make IC independent on temperature variations and transistor parameters variation is called as stabilization. So how stabilization is essential, that is our next point to discuss. How stabilization process can be achieved? What is the need of stabilization? Why stabilization is necessary? Yes, as we have discussed, collector current is dependent on temperature, variations in transistor parameters. So the change in temperature or transistor parameter surely changes IC, collector current. So to compensate that, it is always essential to develop some technique. Increase in IC, again there should be decrease in IC, and that is nothing but stabilization. So basically, what is stabilization? The operating point of transistor circuit, it should be made independent of transistor parameters and variations in temperature is nothing but stabilization. And why it is essential to make stabilization? Because IC is dependent on temperature, collector current changes according to change in temperature, and individual variations as well as thermal runaway. So let's discuss these points. So first, as change in temperature takes place, increase in temperature, reverse biasing, yes, similarly minority charge carriers will get importance, and these minority charge carriers, they will contribute for leakage current, unwanted current, that is nothing but ICBO, it increases. As temperature increases due to the minority charge carriers part, ICBO increases. What is ICBO? It is the collector current between, it is the current between collector and base where emitter is open. Emitter कडून काही फॉरवर्ड बायस दिलेलं नाही आणि तरी सुद्धा collector current, leakage current flow होतोय. That is ICBO. As ICBO dependent on minority charge carriers increase, ICEO will also increase because ICEO is nothing but 1 plus beta. So as these leakage currents they increase, ultimately collector current will increase. It means heat will get generated at the junction and the collector current, because of increase in collector current, Q point will shift into saturation. So always there should be care should be taken as IC should not change whenever temperature changes. So in that case stabilization is essential. So this necessitates to keep IC independent of temperature. Second, beta VB parameters as transistor of the same type gets replaced by another of the same type, transistor replacement. NPN transistor is replaced by another NPN transistor. In that case, beta may vary. The VB requirement may be different. For example, beta will be 65 for one NPN transistor. For another of the same type, it may be 70 or 75, it may be 100. So like that, beta variation will take place, as well as VBE, minimum requirement 0.6 to 0.7 volt. That any variation will make depletion layer to overcome. So if these two parameters they change, as they are not same for any two transistors or even though of same type, as well as increase in temperature occurs, VB decreases. So again VB changes, IB changes, IC changes. Yes, so here it is essential to make IC independent of such variations of transistor parameters. That is the second need. Third one, as the thermal runaway. So what is this thermal runaway? Here it shows that as flow of charge carriers, which is nothing but current, it will increase and therefore heat will increase. As heat will increase, it will increase the temperature. Again, as dependent on temperature, ICBO will increase, ICEO will increase. As ICEO is nothing but 1 plus beta times ICBO. What is ICEO? It is the current between collector and emitter when base is open. Input side configuration, base emitter. So here it shows as temperature increases, ICBO increases, so does ICEO, and finally IC increases. So this cycle, if it is repeated, then this cycle it shows this temperature will go on increasing. If the same cycle is repeated, increase in temperature, increase in ICBO, increase in ICO, increase in IC, again increase in temperature. So this will make heat generated and that will burn that transistor permanently. That will damage that transistor because of overheating, and that is nothing but thermal runaway. So it is essential to keep IC independent on the temperature, that is to avoid thermal runaway condition, self-destruction of transistor due to overheating. So that is the need for stabilization, to make IC independent of temperature variation, individual variations of transistor, and to avoid thermal runaway. So what are the requirements of biasing? Biasing करत असताना आपल्याला कुठल्या कुठल्या पॅरामीटर्सची काळजी घेतली पाहिजे? What are the requirements of biasing? There should be operating point always placed at the center of the DC load line, that is in active region. It should not move either towards cutoff or towards saturation when input signal is applied. Input signal दिल्यावर ऑपरेटिंग पॉइंट इकडे तिकडे शिफ्ट व्हायला नाही पाहिजे, फक्त ऍक्टिव्ह रिजन मध्ये राहायला पाहिजे. पहिला पार्ट. दुसरा, as it shows IC is dependent on temperature, IC independent parameter should be given in that biasing circuit. Biasing circuit ने ती काळजी घेतली पाहिजे. कलेक्टर करंट हा टेम्परेचर वर इंडिपेंडंट असला पाहिजे. आणि थर्ड कुठला सांगितला तर व्हेरिएशन्स इन ट्रान्झिस्टर पॅरामीटर्स. इट शुड बी इंडिपेंडंट ऑफ व्हेरिएशन्स इन ट्रान्झिस्टर पॅरामीटर्स. सो हाऊ टू अचीव, how to arrange such biasing circuits? Yes, that is the next point to discuss about. There are 5 types of biasing methods. First one, fixed bias known as base bias. Second, collector to base bias, which is known as the biasing with feedback resistor. Third, fixed bias with emitter resistor. Fourth, voltage divider bias, and fifth one as emitter bias. So 5 biasing methods that we have to discuss in our next session. Until that, go through all these points. Remember what is amplification, faithful amplification, biasing, Stabilization, need for stabilization, what is thermal runaway, what are the requirements of biasing circuit, and what are the types of biasing circuits.